The last thing we will look at this week is the zonal statistics function. So I include this as part of the terrain analysis, though it's not necessarily a terrain analysis tool, but let's take a look at it. It can be helpful for your site suitability analysis. What are we doing? This is zonal statistics tool. What that does is give us, or it allows us to take raster data, like here we're looking at wildfire hazard potential in 2014, that is raster data, and we can calculate statistics for a defined area. So in this case, we're going to be using a feature class. You could use raster data sets too, like if you wanted to calculate wildfire hazards per land use type or something. So it's calculating a statistic for each zone or zones, or each county in our case, based on the values in the raster grid cells. So one of the things I like to do with zonal statistics is if you search for the zonal statistics tool, you'll get a couple of options. I prefer to use the zonal statistics as a table because then I can join it to my Polygon data set. But you can try the other one too. So I want to use the spatial analysis or spatial analyst one. Our input raster or feature zone data are going to be the features or zones that we're going to be calculating the statistics in. So for this example, if we want to understand the wildfire hazard potential per county in California, we'll select our counties as our feature zone data. I'm going to change the zone field to county name. And our input value raster is our wildfire hazard potential. Now you can see that we have, this is raster data, but it has been classified. So 1 to 5 is very high, and 6 and 7 is non-burnable or water. This can create a little bit of complication with our output table because we have this non-burnable and water data set, or water values on our data set. So you could go through and reclassify these as no data or 0 or something if you wanted to. But I'm going to show you why I'm leaving them in a second. So this will be for hazard potential. I'm going to stick with all the statistics so you can see everything that you get when you do your zonal statistics as a table, and we'll go ahead and click Run. And we'll see that we have a nice table, standalone table that pops up, and we can go ahead and open it. And we will have the 58 counties in California. You'll see how many cells fell within each county. Then you start getting into the statistics that were created from this file. So we have the minimum, the maximum, the range. So these are just, again, classified values, so they don't really mean too much to us. The mean, so the average of all the grid cell values divided by the count for that area. So this could be useful if we just had, if these were just 1 to 7, like low to high, 7 was the highest. But with this 6 and 7 in there, I think that's going to throw a little bit of a wrench in using the mean, because I think the means are going to be artificially high, especially in counties like, you know, we can look at Imperial County, and it's, let's see, where is Imperial? It has a lot of non-burnable areas plus the Salton Sea. So its mean is 4.9, which is almost in that very high category, but it doesn't actually have any it has, oh, we could zoom in, but there's not a lot of very high cells. So this is being skewed by these values. So you could use something like the median value if you wanted, but again, we're getting like 6 for that non-burnable. I like the idea of using the majority and displaying it by the majority. So for here, it would say majority is 6. So it's majority of Imperial County is non-burnable. Let's see, what is this one that's majority water? San Francisco. Well, that makes sense because it's probably including all the water. I probably should have clipped out the water. Yeah. But again, it's still non-burnable, so it's not, mostly non-burnable. So anyway, so you could do a lot of things. I probably should have done a lot of things with this data set, but it'll give you like an idea of what your data set looks like. So we can then go and, sorry about that, we can then start our tabular join. So we'll be joining this table of our zonal output to our California counties. So right click on the counties, joins and relates, add a join. Actually, let me make sure I moved all the joins on here. Joins and relates. Okay. So now we want to join to our California counties table the data set here. So we need to find the two columns that match. So for the counties, we'll look for that county name. And again, over here it should match in our output. So let's validate that. Okay, so it's matched 58 out of 58 records, so that is good. So we'll go ahead and click OK. And now we can close out of here. We can close this attribute table. If we open our attribute table for our California counties, as we scroll all the way across, you'll start to see those zonal statistics being added. So max, min, range, mean, standard deviation, sum, variety, majority. And this is a field that we're going to base our symbology on. So we'll click on symbology. And it's symbology for the California counties. Make sure you have it highlighted, or you can always right click and go to symbology. We want to go to, what do we want to do here? Unique values. We're going to go into majority, and then we're going to remove all other values. We are also going to import the symbology from the data set that I have. It comes with a layer file, which is quite nice. Let's see if that'll let us. It's really set up for raster data, so it might not work. Yeah, feature layer. Okay. Well, we can, let's see. I'll just go back to our symbology. So from here, let's see if it'll let us match to the other one. Yeah, because this is raster data, it's not going to let us do that. But we can go into our symbology. We can look for a similar, let's do graduated colors then, because it will give us be a little bit easier to do. And now we need 7 classes. Let's change this first. And then we're going to look for that blue to green. Hold on. Alright, so I found a symbol pretty close to that symbology, but just to walk you through how I'm doing this, I wanted to match exactly. So I'm clicking on the symbol in the wildlife hazard potential. I'm clicking on color properties. I'm copying the hex code. And then I'll go back over here and go to color properties and add that in there. Well, that doesn't look right, does it? No, it doesn't. That one. There we go. So it'll start to match. So I'm going to go through each of these and fix that. Now I took off the borders because these colors didn't have borders, but I'm realizing we do want the borders, especially on some of these gray areas. So add that back on. And you can go through now and then back in. I'm not going to do that right now. The other thing you can do, as you can see, I started to change the labels, and I'll continue to do that. Kind of added back in some of those borders. So now you can see it gives us an idea of the majority, in each county we're seeing the majority of the wildfire hazard potential for 2014. Doesn't mean that the majority of Los Angeles County is non-burnable and not going to burn, no. But I think it represents like the majority of cells in there. So we can go back and rethink that as well. It's also, you know, some of them are completely water, but again, that's a problem I should have addressed before. But either way, the results you can see from the zonal statistics are that we get the majority of cells and what class they fall into. So we can see in 2014 where the biggest areas of concern were and where some areas of lower concern are.